Hello, everyone. Thanks for joining this session. I know the other session is just wrapping up and it's in the final moments of the Q&A, so we go slow at the start, waiting for everyone to join. I'm delighted to introduce Anjusree, I hope I'm pronouncing it right,
Yes.
from Solaires Enterprises Incorporated from Canada, and they will be telling us more about perovskite inks. Over today and also yesterday, we heard a lot about people printing the perovskite inks, inkjet printing or roll-to-roll processing, but we didn't actually hear so much about inks themselves. So this presentation is about perovskite inks, and as usual, the presentation is 20 minutes. There will be time for question and A at the end, and then after this session, we go into the networking lounge. So you have 20 minutes. You may start 2 minutes before the end. I come in to give you, kind of heads up that time is almost up, and yeah, you may start. Stage is yours.
Thank you so much for the introduction. So I'm Dr. Anjusree Shyla. I'll be representing Solaires for this TechBlink Photovoltaic conference this year. So a little bit of introduction about Solaires and what we do. So Solaires is a clean tech company working towards commercializing flexible perovskite solar cells, which is considered to be an alternative for silicon technology. Our company is located in Canada, in a province, beautiful British Columbia, and in a city, Victoria. We have our labs both in Victoria and Vancouver. We have different partners and customers in different parts of the world with whom we work together in order to bring perovskite solar cells to market. So I'm the research manager at Solaires. I oversee the research collaborations happening within Solaires with different universities, research institutes, and industries. I have over 10 years of R&D experience with a PhD in renewable energy technologies with a specialization in thin film solar cells. So let me provide some background context before actually going to the technology of Solaires. So as we all know, demand for solar energy is always been on the rise and is starting to become a requirement by several governments all over the world. However, there is an increasing worldwide shortage of solar panels due to the scarcity of its main material, which is silicon. Another issue with silicon is its long value chain. Its fabrication process has several steps, which makes it really expensive, long, energy consuming, and produces like lots of greenhouse gas emissions. So taking all this into account, Solaires enables the photovoltaic industry to make solar cells from an abundant and lower cost material called perovskite. Perovskite, in contrast to silicon, has a shorter value chain, a smaller facility footprint, and requires 10 times less capital compared to silicon for its fabrication line. Unlike current silicon solar panels, our perovskite-based ink photovoltaics have lower manufacturing cost, 40% lower greenhouse gas emissions, and enable new innovative applications to address market demands for flexible and rigid translucent photovoltaic solutions with higher efficiency and stability. But the question is perovskite an actual solution towards replacing silicon? The answer can be both yes or no. Why? Because perovskite technology has its own challenges that hinders its path towards commercialization. So there are identified well-known issues that is associated with perovskites. So I just addressed three major issues. Major one is the stability. So as we all know, perovskite is more susceptible for degradation under different environmental factors like moisture, UV, oxygen, etc., thus making the composition really intrinsically unstable. So another issue is the scalability. So we know the device like the perovskite solar cell is a kind of multi-layer system, and each layer is important towards the final performance of the device. And the uniformity of each layer is equally important for proper electronic properties to happen and to deliver a kind of efficiency that we are looking for. But the uniformity of each layer is at stake when it moves from lab to fab. And final issue is the toxicity. The major